Hi, I'm Brian Carlson, Global Marketing Director here at NXP Semiconductors, and I'm involved with the automotive processors. And we're going to see some exciting demos. We just introduced today our S32N55 super integration processors, our first member of our S32N family, all about super integration of vehicle functions, consolidated ECUs within a vehicle in the center of the vehicle. So we're showing two things here today. There's the software side, I would say the software development with the cloud. We're showing here today NXP Cloud Studio, which allows developers to develop their software in the cloud. And then we'll see the hardware, actually seeing physically what it's all about, how it works together, and we'll see user experiences of how the SDV can provide value to the users, as well as seeing some of the value of what the silicon is actually providing. So let me start with the software side. This is called NXP Cloud Studio. This is a virtual development environment. So the old days, you would typically have software running on a board such as this on your desktop. But what we're seeing is with these chips, we have multiple people integrating multiple ECUs, global teams across the world. They need to develop software at a mass scale with SDVs. That involves the cloud. So we basically put all of our tooling, our models of our processors in the cloud. When you go through a cycle with development software for SDVs, it's an infinite loop, and we're showing here an infinite loop. You go through stages of code, build, test. I need to deploy it to the vehicle. I need to actually monitor the vehicle. So we have all these steps with our S32 Design Studio. I'm not going to go through all the details here because of time, but we can build it leveraging Synopsys with our virtual prototype of the S32N processor. We can test it on that VDK, deploy it so we have over the update upgradability, so I can deploy that actually to the vehicle. And then once I'm in the vehicle, I can actually real-time monitor what's going on. Here we're showing the speed, the propulsion. I'm actually can monitor the vehicle. This is the video we captured on the MC test track in Detroit. But you have the ability to monitor. So in a software-defined vehicle, this is a continuous loop called continuous development, continuous integration, continuous deployment, CI/CD. And we provide all of that with NXP Cloud Studio to develop software for SDVs, and specifically on this chip here, we just announced the S32N55 super integration processor. So the second part of this is the other side of the coin as I talked about. Now it's about the hardware, the architecture, the chips, and then all the experiences that are layered on top. And I want to frame this is that we introduced the open CoreRide, S32 CoreRide platform a couple weeks ago. This is showing the demonstration of how all that comes together, a holistic view of how we can have all this coming together across the vehicle. And so we're showing from a hardware perspective, we're showing the whole SDV architecture from the end nodes with actuators and sensors and motor control with the S32K and K1, S32K3 for the zones, so we can actually consolidate functionality through the zones of the vehicle, which is localized processing. The big news today, though, was S32N55. This is our real-time super integration that we do in this part right here, which is a vehicle computer or a central vehicle controller. This has the ability to integrate dozens of functions or even migrate functions from the controller to the central vehicle controller over time. Now, the benefits of that are several-fold. We'll show some of the user experience and capabilities and how we can update very quickly. The old world, we had boxes and every function defined by boxes, hardware defined. Now we're software defined, but hardware enforced to actually allow all these functions to work in a single box. So instead of putting that processor in a box, we're putting boxes into the processor. So one thing I'll show here is, in this example, we have 16 processors, and we can group those in any way we want to in a safe, isolated way. We're showing here chassis, propulsion control, safety systems, power management, battery management, HVAC, body, over-the-air management, and SDV management. We can do all of that on the S32N55 in a safe, reliable, and isolated way. What we're showing here is all of those processors running with different operating systems like AUTOSAR, Zephyr, the ability to run multiple operating systems running in different partitions. Some are running in lockstep, or we see two cores running lockstep for ASIL-D safety applications, others that are multi-core applications, and others that are single-core body that are not critical, functionally critical. So this shows the hardware view of what's going on inside the chip. This is the architecture and how S32 addresses the whole architecture. We also have connectivity to the cloud, so we can actually, much like we showed on the other one, we can show how you can do cloud visualization of what's going on in the vehicle real time. So let me talk about personalization, because personalization, now we switched to the user experience. What does this enable? Personalization's a key one. Tomorrow I'm going to bring my laptop here because if I log in on Wi-Fi. So what I'm going to do here is show how I can use this vehicle and a software-defined vehicle to actually make my vehicle personalized. How do I improve it over time? How do I make it best for me? There's a personalization package in the infotainment. I downloaded that package. That allows me to customize it. Now that I have that, I can place the fob onto this. Now watch the colors, watch what happens. It all turned yellow, but you didn't notice probably that these got brighter, different patterns, the fan goes faster, the wheels go faster, and all of these blocks right here that are in yellow, those are blocks that got personalized for that driver. So we actually can personalize the whole vehicle. We can go very deep in the vehicle to the drive experience, the in-cabin experience. We can control all of that. Now, if I go to the other driver, driver 2, switches to green. That's the eco driver. And then one thing we didn't notice is that the range went up. It went from 140 to 170 because I'm eco. We actually manage how we manage the electric motors. So we're running more eco mode. So the personalization can extend all the way into the driving experience, can extend all the way to the range of the vehicle. And what we're also showing here, the wheels are moving slower, the lights are dimmer. It's just kind of showing how you can personalize it. So that kind of shows the personalization aspect. One other thing that's really key, safety fault recovery. So because of the isolation of each one of these, they're independent and they have freedom from interference from each other. If there's a fault in a non-critical function, we can still keep operating the vehicle and that function does not bring down or impact the other functions. So I can eject a fault. You can see the red here. You can see there was an error in the climate control. Non-critical control function. There's an update that's available that can update. There's a bug in that software. I'm able to update it. Let me run that. So it's doing an over-the-air update. It's going to update this, and it will clear the fault. So that fault that was red is now cleared. It's blue. So it shows you how all of these can independently, mixed criticality functions can run together in a single processor and isolated. I can visually control them, reset them, do over-the-air updates to actually fix issues. And we talked about this earlier offline about how I can actually make my vehicle easier to maintain over time, how I can do updates and do that over the air. This is a good example of how I was able to update that part of the system. The other part is about data intelligence, and we're showing that here too. So we talked about the hardware, the architecture, the chip, what's inside the chip, personalization from a user experience, the ability to fault detect and to improve and do over-the-air updates. So quite a lot is going on here, but hopefully you get an idea of the various angles of software-defined vehicle and all the software development flow that leverages the cloud to do rapid and an agile manner update my vehicle over the life of the vehicle.